Hello students, let us try to understand the hydrolysis of salt of weak acid and strong base. Right student? So we are taking a salt of weak acid and strong base student. So what we can know, so the hydrolysis of salt, weak acid and strong base give alkaline solution because the base is strong student. So its effect will be more. So the give alkaline solution due to the presence of OH ion. The example of these type of salt are CH3COONA, Na2CO3, Na3PO4. For example, CH3COONA is salt of weak acid, that is acetic acid, and is strong base, that is NaOH. It gets completely ionized in aqueous solution. So this is what, so that is salt of weak acid and strong base. It is also completely ionizing in CH3C double minus and Na plus. The acetate ion thus form undergoes hydrolysis in water to give the acetic acid and OH minus ion. So this is acetate ion. It is a water. It is giving the acetic acid and OH minus. The acetic acid being weak acid Ka 1.8 into 10 power minus 5 remains mainly unionized in solution. This result in increase of OH minus ion concentration in the solution, making it alkaline. The pH of such solution is more than 7. Thus, the reaction of hydrolysis of CH3COONA may also be written as. So, this is the salt of the weak acid strong base, but H2O it is giving weak acid plus the strong base. Let us consider in general the solution of salt like MX form by the strong base MOH and weak acid HX. Since salt is strong electrolyte, it is completely ionized into M plus and X minus ion according to the equation. So mx plus h2 it is giving m plus x minus. Okay, since m plus is a cation of a strong base, it remains as such in solution, but the anion x minus react with water to form the unionized acid, that is HX. This process is known as hydrolysis and is represented by the equation x minus plus H2O. It is giving HX plus OH minus ion. Right student. Now you see student, that is hydrolysis constant. So dear student, if you talk about the assuming that the concentration of water remained the constant, the equilibrium constant for the hydrolysis reaction is called the hydrolysis constant, represented Kh is equal to Hx OH minus upon X minus. The following equilibrium also exists in solution Hx H plus X minus. So K is equal to H plus X minus upon Hx. So Kw is equal to H plus and OH minus, multiplying the numerator and denominator of the right hand of equation 1. Okay, this equation. So we get that is Kh is equal to Hx OH minus X minus into H plus upon H plus. So it will give Hx OH minus H plus upon X minus H plus. So Kw upon K, this is the what, X minus into H plus, this is the Ka. So that is Kh is equal to Kw upon Ka. Now it is clear that hydrolysis constant Kh of a salt is inversely proportional to the dissociation constant Ka of the weak acid. Therefore, the weaker acid, the greater the hydrolysis constant of the salt. Now, student, what we have to understand degree of hydrolysis. Okay, so that is we are taking the same salt of weak acid and strong base. So that is X minus, that is anion, is getting hydrolyzed. It is giving acid and OH minus. So Kh is equal to, that is product of molar concentration of product upon the reactant. So this is we are getting Ch square upon 1 minus H. H is very small, so it will give Kh is equal to Ch square. So H is equal to root of Kh upon C. So H is equal to Kh upon now what we can write, student? Kh upon C. You see Kh is equal to what we got for this weak acid is salt of weak acid is strong base. We got Kh is equal to W, Kw upon Ka. So K at the place of Kh we are writing Kw, Ka, and C is as it is. So this is the hydrolysis okay, constant. Now what we can do here, students, so OH concentration is CH, so H plus concentration what will be there, student, because we know H plus OH minus is equal to Kw. So dear student, we can write that is H plus is equal to what we can write, Kw upon OH minus ion. So this is Kw upon OH minus ion, and OH minus ion is equal to what, CH. So H plus is equal to what is coming, student, that is Kw upon CH, right? Substituting the value H from equation 6. So if you see, student, H plus equal to Kw upon C is there, right? And you can write here that is the KH value, KH value. So here it will be root of Ka into C upon Kw. Okay, now H plus equal to Kw into Ka upon C, this. So pH is equal to minus log H plus n, so minus log Kw into Ka upon C. So pH is equal to minus 1 by 2 log Kw plus log Ka minus log C, this is. So now log Kw minus log Kw is equal to pKw minus log Ka equal to pKa. So pH is equal to 1 by 2 pKw plus 1 by 2 pKa plus half log C. At 298 Kelvin, pKw is equal to 14. The equation become pH is equal to 7 plus half pKa plus log C. Thus, knowing the molar concentration of C of the solution, Ka and Kw, the pH of solution can be calculated. So dear student, here is this, the derivation is quite complicated, but we have to memorize that is the pH of hydrolysis of salt of weak acid and strong base will be, that is pH is equal to half pKw plus half pKa plus half log C. So this is all about the pH of hydrolysis of salts.